right. Good day, everyone, and you are welcome to today's section with Isaac Eskin. I'm your math tutor for today's lesson. In today's lesson, we want to explore much about partial derivatives in calculus. Now, with partial derivative, you already know how to find the derivative of a function of a single variable, right? Most of the time, the ones that we knew from probably basic school or senior high is maybe you're given a function f of x is equal to, let's say, x squared. Then you are told to differentiate, so you know that f prime of x is basically going to be 2x, right? Now, these functions are functions of only single variable, one variable. So we are able to take the derivative of this function with just respect to x, right? However, in the case where we have a function of two variables, x and y, we have to take the partial derivatives. And this introduces us to the definition of a partial derivative. Now, a partial derivative measures how a function changes with respect to one variable. How a function changes with respect to one variable while keeping the other constant. So this is the definition of a partial derivative. So here we want to see how a function changes with respect to a specific variable or one variable. Don't forget that here, just as I said, we are dealing with multiple variables here, a function that has two variables or multiple variables, right? So here we find the derivative of the function with respect to one variable, and then we keep the other variables as constant. This is the definition for the partial derivative. So for example, imagine if we have a profit function denoted by f of xy. So this is a profit function, right? Here the x may represent, let's say, the number of labor needed. The y may represent the capital needed to produce. So f is just a function consisting of what? Labor and then capital, which is x and y. So if you take the partial derivative with respect to x, if you take the partial derivative with respect to x, what it means is that we want to see how the profit function changes, how the profit function will change as labor changes. Of course, labor is x, right? That's what we said. We said x is labor. So if you take the partial derivative of f with respect to x, now what it means is that we want to see how the profit function, which is represented by this, changes as labor changes. It's the same way for y. If you take it with respect to y, you want to see how the function changes as capital also changes. So mostly we are measuring the rate of change of a function with respect to a particular variable. In mathematics or in calculus, we denote the partial derivative by this symbol. Mostly we call it delta. So if we are differentiating f with respect to x, then we mathematically write it as this. So del f del x. If it is y, we have del f del y. Now in other books, sometimes you see them writing, if f is the function, you see f subscript x can also represent the partial derivative of x. Or we can also have f subscript y. So now let's pick an example. Maybe we choose a function and then we try to find a partial derivative of it. Let's look at this simple example. Now in this example, we have that f of xy is equal to x squared plus 3xy plus y squared. So we want to find the partial derivatives with respect to x first before we do for y. So we want to find the partial derivative of f with respect to x. Now it is the same way, when you are finding the derivative of a function whereby we have only a single variable, right? A single variable function. It's the same thing. So here what it means is that we are only going to differentiate the term that contains x, and then we will treat the other ones as constant. So here, when we differentiate this term, which is x squared, we are going to get 2x. Plus, if we differentiate 3xy, don't forget that here we are only differentiating with respect to x. All other variables are treated as constant. So here y is just a constant, right? So if we differentiate 3xy with respect to x, we are going to be left with 3y. Now in this term, which is y squared, there is no x here. And of course, we are treating this as a constant. So if you differentiate, you're definitely going to get 0. So the partial derivative of f with respect to x is 2x plus 3y. Now let's do the same thing for y. So the partial derivative of f with respect to y. So in the same case here, we are differentiating with respect to y. So only the terms with y, that is what we are looking for. Now this is treated as a constant. So x squared, when you differentiate it, you get 0. Now when we come here, when we differentiate 3xy with respect to y, we are going to get 3x. Plus, when we differentiate y squared with respect to y, we are going to get 2y. So the partial derivative of f with respect to y is 3x plus 2y. As simple as it is. Alright, so try this out. Try this second example out. Now f of xy is equal to 4x squared minus 3xy plus 2y squared. This is what you want to do. You want to find the partial derivative of f with respect to x. And then you also want to find the partial derivative of f with respect to y. Then you are going to find the partial derivative of x, the partial derivative of f with respect to x twice. This is what you want to do. And you do the same thing for y. Don't worry, I'm going to explain this one to you. You first do the first two. The partial derivative of f with respect to x and that of f with respect to y. Then here, you will do it together. So pause the video and try it out on your own. After that, come and let's compare the solutions or the answers. So I believe that now you have tried it on your own. F of xy is giving us 4x squared minus 3xy plus 2y squared. So we want to find the partial derivative of f with respect to x. So we go through the same steps. Of course, when we differentiate 4x squared with respect to x, we are going to get 8x minus, if we differentiate 3xy with respect to x, we are getting 3y. Then here we do not have any x term, so this is treated as a constant, hence the derivative goes to 0. So that is the first one. Now with the second one, we want to find the partial derivative of f with respect to y. Of course, in this term there is no y, so this is constant. The derivative is 0. Now in this one, the partial derivative with respect to y will give us negative 3x. Then the partial derivative with respect to y is going to give us 4y. So these are the first partial derivatives. Now this one, I just introduced this one so that we can learn it as well. Now this one is, so these ones, the earlier ones that we did are the first partial derivatives. So if we take the partial derivative again from the first ones, we have the second order partial derivatives. What it means is that given this first partial derivative, we are going to differentiate this function again with respect to x. That is what it means. It means we are differentiating it twice. So this is the first one, and we are going to differentiate it again to get this, the second order partial derivatives. So let's differentiate this with respect to x. Now this is going to give us 8. Of course, when we differentiate this with respect to x, we are getting 8. On this side, we'll get 0 because y is a constant. So we treat it as a constant. We treat y as a constant. So the derivative will be 0. Now, the fourth one is the partial derivative. Now we take the second partial derivative of y with respect to y, sorry. So here we already know the first partial derivative, which is negative 3x plus 4y. Let me write this well. So 4. So in differentiating this function again with respect to y, now you can see that here there is no y term here, so it goes to 0. Now when you differentiate this with respect to y, you are getting 4. Yeah, so I intentionally introduced this to you. This tells you that we can differentiate a function n times, right, with respect to the variable n times. So this is the second order partial derivatives. We can even have the third, where it is also denoted by the partial derivative of f with respect to x 3 times. This is the third order partial derivatives. But for this lesson, let's limit ourselves to just the first and then the second. And so now I believe that you are an expert. You can take the partial derivative with respect to any variable of any function that is given. Thank you for watching today's lesson, and I believe that this piece of video was resourceful, and then you were able to understand the concept here. Now I'll meet you in the next section, and I hope that in the next section you will also join as well. Have a nice day.